This video will show examples with infinite geometric series. Find the sum if possible. The first step is to determine if the sum is finite or not. We can do this by inspecting the elements. If we look at them, we can see that the magnitude of each of the elements is increasing, meaning that the absolute value of r is greater than 1. So that means that it is not possible to find a sum. If we look at the elements of this geometric series, then we can see that each of the elements is decreasing in magnitude, meaning that the absolute value of r must be less than 1. We can check this by actually computing the value of r. So r equals the second term over the first term, which is negative 0.25, and that actually does have an absolute value less than 1. So now we can use our formula for the sum. G1 is equal to negative 5, and then 1 minus negative 0.25. And if you calculate that out, it ends up being negative 4. Here we have the exact same series from last time, except that all of the terms are positive. So again, we see that the terms are decreasing in magnitude. So absolute value of r is less than 1. r is equal to 1.25 over 5, or 0.25. We'll take our formula for the sum again. G1 over 1 minus r. Plug in the values we have, so that ends up being 5, 1 minus 0.25, and so our sum is 20 over 3. Here we want to convert a repeating decimal into a fraction. The way we do this is we write our repeating decimal as a geometric series. And from looking at these first few terms, we can see that G1 equals 0.238 and r equals 0.001. So we can plug this into our formula. G1 over 1 minus r and so here we have our fraction. There's an alternate way for doing this. We can write that our number s equals 0.238 plus 0.000238 all the way down. And then we can multiply s by 1,000. And what we end up with is 238 plus 0.238, etc. Now, if we subtract the first equation from the second equation, we can end up with 999s equals 238 because all of the other terms behind here cancel out. And then we can solve for s by just dividing both sides of the equation by 999.